Welcome to Chapter 0, Section 13, Representing Data. So some vocab words for you is frequency table. And that uses tally marks to record and display frequencies of events. A bar graph then compares categories of data with bars representing the frequencies. So here I got lazy and quit marking my tallies, but you get the gist of what that should be. So there should be 15 tallies here, and so forth. But we want to make a bar graph to display the data. So what we're going to do is here's b-ball, football, volleyball, and softball. Okay, our basketball, we're going to go up by 5. So 5, 10, 15, 20, 25. This isn't perfect. Yours should be scaled out. Okay, they should look nice. There's graph paper for you to use to get to this. Mine aren't going to be perfect because I don't have a graph paper on here. But your graph paper is in the back of the classroom. You can use that and you can get a nice graph. So our basketball is at a frequency of 15. So it goes up to the 15. Boom. Football, 25. So it goes all the way up to the 25. Volleyball is at 18, so it's somewhere in between this 15 and 20. And then softball is 21, so it's a little above the 20. So there's our bar graph displaying our data. That's simple. Now we have a cumulative frequency. So that's the sum of an event's frequency and the frequencies of all the preceding events. So every event before it is added on. A histogram is a type of bar graph used to display numerical data that have been organized into equal intervals. So a histogram has down here where we did our categories, they're numbers instead of equal intervals. So make a histogram and a cumulative frequency histogram. So our first histogram we're making, 5, 10, 15. Like I said, mine aren't beautiful. Yours should be. And then down here we've got 40 to 44. So they're separated in groups of 5. 45 to 49. And these should be equally spread out as well. So 50 to 54. 55 to 59. Like I said, mine aren't beautiful. Yours should be. So those go. There's our label there. Okay, we know that's 60 to 64. And here's 65, as I wrote that backwards, to 69. I'm really sorry that this is not the most beautiful histogram you've ever seen, but you get the gist. Here, 40 to 44 is at 2. 45 to 49 is at 7. 50 to 54 is at 13. 55 to 59 is at 12, so just a little less than that one. 60 to 64 is at 7, so it matches up. 65 to 69, I apologize, is at 3. So that's what our histogram would look like. Our cumulative frequency histogram would look something like this. So our age is greater than, or not greater than, less than. So presidents that were inaugurated, I wrote that correctly too, less than 44, because it's from 40 to 44. So if they were less than 44, there were 2 of them. Now we're going less than 49. So that means everything before it as well. So 7 plus 2, so 9. We got less than 54. So 13 plus 9 to get us 22. Less than 59. 12 plus 22 to get us 34. Less than 64. So 34 plus 7 to get us 41. And then less than 69 to get us 44. So what we're going to do here now is I'm going to erase our old histogram. You saw how that was shaped there. So you saw it went up and then down. So most of the presidents were inaugurated in this chunk here. So around 50 to 59. Now we're going to see how it grows each year with our cumulative frequency table. So we've got our graph. Oops, I didn't leave any room for a label there. Here we've got less than 44, less than 49, less than 54, less than 59, less than 64. And like I said, I expect your graphs and charts to look way nicer than mine. And now I need to get up to 45, so I'm going to count by tens. 10, 20, 30, 40, 50 up here. And so 44, it was at 2. Less than 44 is at 2. Less than 49 is at 9. Less than 54 is at 22 now. Less than 59 is at 34. And mine are just estimates. Yours should be perfect. Less than 64 is at 41. And less than 69 is at 44. So you can see the biggest changes were in this time period of 54 to 64. Just like before, when that was where the most was, that was where the greatest change would be. So now a line graph shows how data changes over a period of time. So we want to make a line graph of our data here for the Bulldog Cafe. So what that one would be on your graph paper is you've got September, October, November, December, January, February. I'm just going to go up to February because that's all I have room for. And then you've got your money over here. So 100, 200, 300. And yours should look way nicer. September's off the chart, so I'm not graphing it. October was at 229. So it's something like that. November, 300. December, 168. January, 290. February, 388 off the chart. And then you link all of your pieces together. So it creates a line, and you can see where the ups and downs in your graph end up. You've got your stem and leaf plot. So your stem is your first chunk of numbers here. So that would be 3s, 4s, and 5s. And your leaves would be in order, so you'd have 40, 0. And you mark for each one. I'm just crash coursing this because this should be a review for you. 60 and 72, don't forget them all. So 61, 70 has a 0, 50 has 2 zeros. Making sure you cross them off so you get everything in there that you need to have. So your stem and leaf plot is your bases and then your ones. So your tens and your ones, or your hundreds and your tens, and then your ones on the right side. A circle graph is a graph that shows the relationship between the parts of the data and the whole. The circle represents all the data. So your whole circle, in this case, is cut into 3, 4, 5, 6, 7, 8 parts. So 4, I'm chopped into 8 parts. And then I'm going to use highlighter. So canoeing represents 3 of those parts. So 1, 2, 3 are canoeing. Crafts is 1. So crafts fills in 1. Eating is 2. So eating fills in 2, and then we'll leave hiking at white, also taking up 2 spaces. So you can see this way. using a circle graph. The whole graph represents everything. You've got a box and whisker plot. So what a box and whisker plot is using our 5-number summaries. So we need our min, our max. So you've got 8, 13, 14, 16, 16, 18, 18, 20, 20, 22, and 30. 22, 30. Then we're going to go find our median. Boom, 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 boom. 18 is our median, our quartile 1. Boom, 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 boom. That's 14 is Q1. And Q3 is 20. This is our min. This is our max. So you need to use a legitimate number line that's shifted out. So you've got 8 as your smallest. Say we're going up by 2. So 8, 10, 12. They should be equally spaced. So be using that graph paper. Okay, so we're going to pretend like I had enough space, so we're going to mark this as 30. So our max is one of our whiskers. Our min is one of our whiskers. Our quartile 1 of 14 is the outside of our box. Our quartile 320 is the other outside of our box. Our mins are connected. And then our median of 18 is a line inside of our box. So you can see the spread of your data this way. So when you compare data, drawing a double box and whisker plot, that's one plot, one box and whisker, so say it looked something like this, on top of the other. So your other one may have a wider interquartile range with more of your data skewed to the top. That kind of thing. And then you can compare your data. I'm skipping ahead to save some time. If you have questions on this, please ask me. I will get another video up soon that has all of the data. And then finally, which type of graph is the best way to display each set of data? So what you would do is you would test or look at this and see the result of a women's Olympic high jump event from 1972 to 2008. I want to see that in a line graph so I can see the changes in the heights from the older years to the newer years. The percent of students who have 0, 1, 2, 3, or more than 3 pets, that would be a circle graph. So you can see all of the different shapes or how much each chunk takes up.